Right, in this very first lesson of pre-AP biology, we are going to learn about the cycling of matter. Our guiding question for this lesson is, how are elements and molecules related? You should have your guided notes out in front of you and have a pencil ready to start taking notes. So, as you've probably learned in middle school, matter is never destroyed or created. You always have the same number of blocks, the same number of matter, just kind of cycling through the earth. The building blocks of matter are constantly being rearranged to make different things, and let's explain what we mean by that. Okay, so first of all, the building blocks of matter are called elements. In biology, the elements are as far back as we go, and these are represented by one or two letters. So for example, C represents carbon, H for hydrogen, oxygen, nitrogen, phosphorus, and sometimes you have elements that are two letters, okay, calcium, neon, and helium. But that's, yes, we represent those by one or two letters, okay? Each of these elements has differences in weight. They differ in their ability to connect with other elements, how they behave, how they smell, how metallic they are, all sorts of characteristics. If you look at the periodic table of the elements, this looks really complicated, partly because it is, but there are all sorts of elements that fall into different categories of metals or transition metals or noble gases or metalloids even. Okay, so these are some of the elements that have been discovered in the world, and each of them varies in their different characteristics. Here's an example. Iron, we have the chemical symbol and its atomic number, its weight, and how it behaves. Well, it behaves like a transition metal, and I'll let your chemistry teachers teach you more about that. Some other examples are shown here. We've got carbon, and next to it is nitrogen and oxygen. Given the fact that they have a similar color here, probably means they behave in a similar way, or maybe they just have a similar weight. Okay, but they're all very unique from each other. Okay, so we have carbon, nitrogen, oxygen, aluminum is here. We know that aluminum can be used in foil. So chlorine you put in your pool, all sorts of different functions. Okay, now an important point to make here is that elements rarely occur alone. We don't often just have an aluminum element or carbon element. They often have friends. They pair up with other elements. And that's where molecules come into play. A molecule is two or more elements combining together. Okay, so an oxygen gas molecule would be two oxygen elements bound together. Nitrogen gas molecule would be two nitrogen elements together. Water is two hydrogens and an oxygen. Carbon dioxide is one carbon and two oxygens. Okay, so each of these is an example of a molecule. Depending on how many of which element are present, and that's what I mean by composition, you're going to have a different function. So oxygen gas, again, is two oxygen elements put together. This is what we inhale during respiration, right? We take that into our lungs. It gives us life. Wonderful things happen. When you add a C, a carbon, to those two oxygen elements, this becomes the molecule that is a waste product that we end up exhaling during respiration. It's a very different function. Okay, let's compare oxygen gas. So two oxygens together, if you add one more oxygen to that, you end up with ozone. This is a completely different compound. This is the ozone layer that surrounds the Earth and keeps in greenhouse gases and heat and all sorts of things. Let's take another look at another example. Water is H2O, two hydrogens and an oxygen. Let's add one oxygen to this. You get H2O2. This is hydrogen peroxide. Okay, clearly a different function from water. We would never drink hydrogen peroxide, and we wouldn't put water on our cuts. Well, maybe we would, but different function. Okay, one last example here. Carbon dioxide is a waste product that we, obviously exhale out. That's one carbon and two oxygens. Let's take one oxygen away from that molecule and we get carbon monoxide. Okay, this is a very dangerous compound that we even have sensors in our house for because it can kill us. So clearly that is a different function from just CO2 that we exhale. Now, the universe is like this Lego bin. The universe is made up of the atmosphere, the geosphere, the hydrosphere, and the biosphere. This is otherwise known as the air, the soil, the water, and the part of the world that's comprising living organisms. The elements and molecules are constantly cycling through all of those spheres, and they're being rearranged into different things. Okay, so the C in the CO2 might be taken and made into glucose, right? C6H12O6 in a tree, and that might go back to CO2 at some point, but the same number of elements are going to be found in the world, and that will never change. They're just constantly being rearranged and restructured.